Broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, I'm Matt Keeley and welcome to today's webinar, which is hosted by the Clean Energy Solutions Centre in partnership with the Pacific Region Infrastructure Facility, or PRIF. Today's webinar is focused on the recently released Renewable Energy Costs in the Pacific report, where PRIF analyses the capital costs of large solar photovoltaic, wind and hydro generation projects built in the Pacific over the last decade. Change slides. Before we begin, I'll just go over some of the webinar's features. For audio, you have two options. You may either listen through your computer or over your telephone. If you choose to listen through your computer, please check the mic and speakers option in the audio pane. If you want to dial in by phone, select the telephone option, and a box on the right-hand side will display the telephone number and audio pin. Next slide. If you would like to ask a question at any stage throughout the webinar today, we ask you to use the questions pane where you may type in your question. If you'd like to review the webinar or share this information with others, as an audio recording and presentations will soon be posted to the Solution Centre training page and added to the Solution Centre YouTube channel. Please change slides. Finally, one important note to mention before we begin our presentations today is that the Clean Energy Solutions Centre does not endorse or recommend specific products or services. Information provided in this webinar is featured in the Solutions Centre's resource library as one of the many best practice resources reviewed and selected by technical experts. So today's webinar agenda is centered around the presentations from our guest panelists, Joe Wider, and additional commentary from Anthony Maxwell and Paul McCumbee, who have joined us to discuss renewable energy project costs in the Pacific region. Before we jump into the presentations, I'll provide a quick overview of the Solution Centre, and then following the panelists' presentations, we'll have a question and answer session where the panelists will address questions submitted by the audience. At the end of the webinar, you'll be automatically prompted to fill out a brief survey. We so thank you in advance for taking a moment to respond to this. The webinar is provided by the Clean Energy Solutions Centre, which is an initiative of the Clean Energy Ministerial. The Solution Centre focuses on helping government policymakers design and adopt policies and programs that support the development of clean energy technologies. This is accomplished through access to no-cost expert policy assistance and capacity building activities, such as this webinar. The Clean Energy Solutions Centre is co-sponsored by the governments of Australia and the United States. Change slides. The Solutions Centre is an international initiative that works with more than 35 international partners across its suite of different programs. Several of the partners are listed on this slide and include the Pacific Region Infrastructure Facility, or PRIF, our co-host for today's webinar. Next slide. Our marquee feature of the Solution Centre provides is expert policy assistance, known as Ask an Expert. The Ask an Expert service matches policymakers with one of the more 60 global experts selected as authoritative leaders on specific clean energy finance, regulation, market and policy topics. We offer this assistance to eligible governments free of charge, and requests can be submitted through our simple online form at cleanenergysolutioncentre.org/expert. Next slide. The webinar is being conducted in partnership with the Pacific Region Infrastructure Facility, or PRIF. PRIF is a multi-development partner coordination, research and technical assistance facility which supports infrastructure development in the Pacific. The members include the Asian Development Bank, Australian Aid, European Union, the Japan International Cooperation Agency, New Zealand's Ministry of Foreign Affairs and Trade, the United States Development of State, and the World Bank. Please change slides. So quickly before we get started on today's webinar, I'd just like to provide an overview about you, the participants. So we have over 130 people registered for today's webinar and currently have over 50 registrants logged on at the moment. The registrants are based in as many as 30 different countries across the world, primarily from Australia and New Zealand, but we also have a significant proportion from the broader Asia-Pacific region as well as the rest of the world. In terms of industry, approximately half of you are working in the energy, chemicals or utility industry, with a sound proportion from consulting or working at some level of government. We are so very much looking forward to this diversity being reflected in the questions you ask during the Q&A session. So our first presenter today is Joe Wider, who is the Projects Manager at ITP Renewables and lead consultant of the PRIF report being discussed today. Joe joined ITP Renewables in 2009, and his role involves managing a range of energy policy, generation feasibility studies, investment and deployment projects. Previously working with the Australian government, he has now more than 22 years experience with renewable energy generation and storage, as well as energy efficiency projects in remote locations in Australia and the Pacific. So you'll probably sick of hearing my voice there now, so I'll let Joe take it at wheels. Over to you, Joe.
Good morning, everyone. I'm Joe Wider from ITP Renewables, and I'll give a brief overview of the renewable energy costs in the Pacific assignment. Oops. Hopefully you can see my first slide now. This work was done for PRIF. The objective of the work was to improve renewable energy infrastructure design and implementation in the Pacific through the provision of cost data. As of 2018, around 26% of installed generation capacity in the Pacific is renewable based. While this sounds impressive, it's referring to rated power, megawatts, not annual generation megawatt hours. All Pacific Island countries have set ambitious renewable energy targets. It is important to note that these targets are actually for the electricity sector and refer to the proportion of annual generation met by renewable sources. So achieving them is going to require significant investment in renewable generation and associated enabling equipment. The assignment aimed to collate available cost data for large solar, wind and hydro projects in the Pacific from the last decade. I commenced the work in March 2018, with the first task being the literature review. Previous analysis of renewable generation project costs in the Pacific indicated that data availability, quality and consistency were going to be a major challenge. This was highlighted by ITP's recommendation from 2011 on the need for systematic collection and publication of the cost of renewable generation projects in the Pacific. There's also the issue that rooftop PV systems have different cost drivers to ground mount PV systems. While this assignment focused on larger PV systems, some rooftop PV costs were collected and some projects included both rooftop and ground mount PV without separate costings. Car park shading and floating PV is also becoming more viable and popular, and that's a trend to watch in the future. On the topic of rooftop PV, I'd like to make the point that many utilities prefer large ground mount PV systems, as they may be able to own and control the PV system and benefit financially from it. However, there are many advantages to distributed rooftop systems if roof areas are structurally sound and unshaded. Though I do acknowledge rooftop PV can be more expensive on a dollar per watt basis due to construction access issues and their smaller size. As the benefits of rooftop PV systems may not go to the utility may be reluctant to actively encourage this sector. I believe this is a missed opportunity and would like to suggest that aid funders and Pacific governments strongly encourage and incentivise utilities to publish their rooftop PV feed-in tariff, policies, standards and guidelines. To achieve ambitious renewable energy targets in the Pacific, growth in both rooftop and ground mount PV will be required. The literature review found limited detailed published information on renewable generation costs in the Pacific. Thus, the report includes this interesting figure from Castalia's presentation to the Caribbean Renewable Energy Forum. The figure shows the levelized cost of electricity, or LCOE, from renewable generation compared to just the fuel cost of fossil fuel generation. It shows that both solar and wind are now competitive in the Caribbean. And to provide some context, I've converted the fuel cost per barrel to US dollars per litre, though it should be noted that international bulk oil prices are different to the delivered cost of diesel on an island. It should also be noted that a large amount of assumptions are required to estimate the LCOE from the announced capital costs of renewable generation project. These assumptions include capacity factor, operation and maintenance costs, or OPEX, and discount rate. In addition, the fuel cost of fossil fuel generation is indicative only, as there's a wide range of average fuel efficiencies for diesel powerhouses. I've seen figures as low as 2 kilowatt hours a litre for small outer islands to above 4 kilowatt hours a litre for main powerhouses with multiple gensets that are well maintained. There's also the issue that variable renewable energy generation, such as solar PV and wind, can only be added up to the hosting capacity of the particular connection point, grid and load, after which expensive integration equipment such as batteries will be required to ensure the ramp rates are manageable and power quality is maintained. There's also the issue of fluctuating crude oil prices and the costs of refining and diesel fuel delivery. This figure shows the inflation-adjusted price for a barrel of oil, as opposed to the nominal price, which was the actual price in each year. The World Bank has used a horizontal line to show the average. However, if you were to do a more recent trend line, you would note that the trend appears to be increasing prices and increasing volatility for this finite resource. Pacific Island countries are likely to be paying significantly more than the Singapore bulk diesel fuel price, which was around US dollars 65 cents a litre in September 2018. So to undertake the assignment, we obtained a copy of ARENA's Pacific Project spreadsheet and developed a list of projects to seek cost breakdown information. The information in ARENA's spreadsheet was expanded through extensive web searches to try and find project details. And an overview of the projects is provided in Annex A of the report. There were many challenges in collating consistent project information, including most information on websites is undated. Where dates are provided, it can be unclear if it's the funding approval date, the tender open or close, the contract award, construction start or commissioning, or the date of the project launch. Additionally, most published information on PV projects does not identify if the capacity reported is DC or AC, when ideally both should be reported due to the trend to higher DC to AC ratios. And some projects have different capacities on various websites, and information on batteries, power and capacity is often inadequately documented, with limited information on battery inverters, discharge rates, rated or usable capacity, and some projects appear to have scope changes over the project life cycle. There are more than 70 projects in Annex A, and consultation with the steering group for the project assignment identified around 40 of these projects to focus the effort for obtaining cost breakdowns. The projects list was used to produce this dollar per watt figure, which is figure 6 on page 14 of the report. A significant proportion of projects are excluded from this figure due to there being insufficient budget or date information, as well as projects including other infrastructure in their announced funding. The orange squares are the PV only projects, purple diamonds are the PV battery, wind is the blue X, and hydro the green triangle. There's was limited information and data points for the wind and hydro projects, so their trend lines aren't graphed. It should also be noted that the project costs used are mostly from public announcements, and this can be different to an EPC's tendered amount. However, it does provide a good overview of the variability of project costs and trends over time. I acknowledge that dollar a watt is not a good metric for PV battery projects due to the variety of battery sizings feasible. However, the figure's main purpose was to illustrate variability and broad trends. Feedback on the draft report indicated that a comparison with the diesel fuel cost of generation would be interesting. However, as mentioned earlier, this requires a large amount of assumptions to convert a CapEx to a levelized cost of electricity. So to create this figure, a large amount of assumptions were required. We've been conservative and we've used a PV capacity factor of 18% or 0.18 in year one, and linearly degrading to 14.4% over 25 years, and a discount rate of 7%. The diesel fuel cost lines are only the fuel cost of generation, and we've used an efficiency of 3 kilowatt hours a litre. So the bands of colour have been used around the trend lines to illustrate that these lines are indicative. But what it does show is it shows that PV fuel saving systems are now cheaper than the fuel cost of diesel generation. The addition of a battery increases the LCOE due to the high cost of batteries and the assumed 80% round trip efficiency of the battery. However, the PV battery option can be cheaper than the fuel cost of generation when the delivered cost of diesel is high. Obviously, there are numerous site-specific factors, and this is an illustrative overview only. So I'll just briefly discuss the cost breakdowns analysis, but unfortunately the details of this analysis are commercial in confidence, so that section of the report hasn't been published. There are many challenges to obtaining cost breakdown data, with the main one being the commercial in confidence nature of a lot of most cost breakdowns in most tenders. There's also the issue that proponents provide very different levels of detail on their cost breakdowns. For Australia's Regional Australia Renewables Program, it was expected that the PV projects would all break down their costs according to the categories shown here. For a simple PV project with no battery or wind turbine, it was expected that costs would be reported across 18 categories, which looks fairly straightforward. However, the proponents report their CapEx breakdowns showed a wide variety of ways people break down their costs. Here you can see a small normalised sample that all have different contractual arrangements and definitions. This makes like-for-like comparisons very difficult. The cost breakdown template developed for this assignment is based on the template developed for the RAR program, and I'd like to acknowledge and thank Akistica, who developed the RAR cost template. The cost template is available for download from the ITP website, and I recommend it be made a mandatory requirement for all renewable generation project procurement tenders to improve consistency of data and documentation of what is being installed. The web link is on the next slide. This is what the top half of the template that I used for the assignment looks like. The top section is of the templates for component details and dates. I don't expect you can read the details, but it's basically orange is the PV section, blue is the wind section, green is for hydro, and purple's the battery, and then there's load management, other, and generation infrastructure. You'll also note that the last column is to track whether the information is public or commercial in confidence, with a blank cell indicating the data is commercial in confidence. The second half of the template is where the component costs and notes were recorded. I haven't shown it here, but please download the template from the website if you'd like to examine it. At the end of the template is a web link to the RAR data spec, which has definitions of some key terms. However, the template has been developed to be as user-friendly as feasible, so it should be fairly straightforward to fill in. Analysing the component costs of battery banks was particularly challenging. While PV has its complexities with DC ratings often being different to AC ratings and the issue of many projects requiring spare PV panels to be provided, batteries are significantly more complex. This table is to illustrate that the often used metric of dollars per kilowatt hour has a lot of fine print that often isn't clearly documented. It is also worth noting that while lithium-ion batteries are more expensive, their expected longer life may see this technology become standard for future PV battery systems. To further illustrate the complexity of batteries, this published figure indicates that the battery was 37% of the Tokelau project cost. Analysing the raw data, this could be interpreted to be around $320 per kilowatt hour. However, another interpretation of the raw data, which includes some battery protection, charge controllers, racking, and other essential battery balance of system components, could come up with a figure closer to $500 a kilowatt hour. Some of the tenders examined were lacking in detail on what costs are allocated to the battery and what costs are allocated to the battery inverter and balance of system. Both the dollar per kilowatt hour figures previously mentioned are also simple in that they are based on total capacity, not usable capacity. Factoring in a maximum depth of discharge of 50% doubles those dollar per kilowatt hour costs. This illustrates another issue for comparing batteries in that simple dollar per kilowatt hour may not take into account the depth of discharge or the design depth of discharge. I was also surprised in many of the tenders that I examined on the lack of documentation on the discharge rate for the battery capacity. So the key findings were shown on this slide. The work undertaken to develop these cost breakdowns was challenging due to the range of factors, including the lack of detailed component and cost data, tenders itemising costs in a variety of ways, limited information in financial tenders, and lack of date and currency exchange assumptions in some tenders. The rate shown here for the PV frames has a large range, and that's because some tenders include some of the footing components in this cost item. The battery cost of $200 to $750 a kilowatt hour is likely to be misleading due to the variety of inclusions and exclusions possible for batteries and the lack of detailed information on capacity methodologies. Overall, the unique features of remote Pacific Island countries leads to a wide potential range and higher the costs for renewable generation projects. So PV costs have declined significantly, and there are now opportunities to increase self-reliance and reduce fuel imports. Remote sites such as those in the Pacific leads to higher costs for renewable generation projects. The range of costs for civils and earthworks also indicates that cost savings may be feasible by preparing the site as much as feasible with local contractors before tendering for PV systems. So there are many data gaps for renewable generation projects in the Pacific. This could be improved by aid funders requiring project cost breakdowns to be published in a consistent manner. Information is presented with a variety of levels of detail and date information. A standard template would improve data collection. The lack of documentation on whether PV capacities are AC or DC can also cause confusion. Similarly, there is often a lack of detail when discussing batteries. Reducing bid risk premiums by writing more detailed tender specifications with clear executive summaries is worth considering. And obviously any future work should also consider including OPEX to take into account factors such as performance, battery life, and inverter replacements. And just finally, a quick plug for ITP Renewables. IT Power Australia rebranded as ITP Renewables a few years ago, and we're part of the ITP Energize group, which has its head office in the UK. I'd like to thank the many stakeholders that provided data for this report and the contributions from the PRIF Energy Steering Working Group to provide guidance, feedback, and contacts for this assignment. If there's one key takeout from this talk, it would be to improve tender documents, executive summaries, and use the cost template. Please also feel free to modify and improve it for your particular projects. Thanks for your time, and I look forward to further discussions.
Thanks, Joe, for those great comments. While we just load up the slides here for the next one, I'd just like to, as a reminder, that if you have any questions for Joe's presentation at all or for the report in broad, please submit using the question pane at any time, and we'll come back to them during the Q&A session. We'll have plenty of time to address lots of questions, so hopefully we use this as much as possible. So to start the next session of this webinar, we'll hear from both Paul Macumbe and Anthony Maxwell, who will provide some commentary on the report and have some questions for Joe. I'll introduce both speakers together before starting off with Paul's comments. So first we'll hear from Paul Macumbe, who is CEO of the Sunergise Group. Paul has extensive senior leadership experience across the ANZAC and Pacific regions. As CEO of Oceanic Communications Limited, he grew the organisation into a multinational organisation in 6 countries and was awarded 3 prizes in the Fast 50 competition. Paul is responsible for the day-to-day operations of the company. Next slide. After Paul, we'll have our final speaker, Anthony Maxwell, Principal Energy Specialist of the Asian Development Bank. Anthony has over 24 years experience in design and financing of power infrastructure. Since joining ADB in 2004, Mr. Maxwell has worked in 17 countries across Central Asia, East Asia, and the Pacific. Mr. Maxwell joined the Pacific Department in 2008, where he has led over 16 energy projects worth over $1.03 billion, focusing on renewable energy. Prior to joining ADB, Mr. Maxwell worked as a consulting engineer in Australia, Southeast Asia, and People's Republic of China. So over to you, Paul. Next slide, please. Over to you, Paul, to kick off this session.
Thanks, Matt. Firstly, welcome everyone, and thank you for participating in this webinar. Joe, thank you very much for a very comprehensive report. I think it's probably one of the best reports I've seen that captures in the way renewable energy costs are being compiled and what we're experiencing in the market. I only have a couple of comments that I would make, and then I'll ask Joe a question a bit later on. What is quite clear for us, having been operating in the region for the last 7 years, is that all costs effectively start off the same, from whether it's manufacture or where you ship them in from. But as you get into each country, there's a lot of variability that happens that causes costs to be different, some higher, and almost, in some cases, as a private developer, almost unmanageable for us to proceed with any projects. The key cost components that we've seen very different, and I think Joe touched a little bit on this. As you get closer into the transportation, shipping into different countries will differ depending on how much cargo is being shipped into that country, either from China, from Australia, from wherever equipment is being imported from. And then internally itself, there's a lot of variability of cartage costs depending on the amount of available transport solutions. Labor, we're seeing this, across the Pacific in our experiences, that from a solar technician point of view, installers, the labor rates are pretty much they're very similar, and we're starting to see a whole lot more people participating in this industry as the number of projects are increasing. And that's a positive sign, because it just means that there's a lot more people who, one, are there to deploy the equipment, but more importantly, to ensure that there is available labor that is capable to manage these equipment, which are put in the ground to last up to 25 years. Insurance costs, that's one thing that we've seen that varies across the region quite dramatically. To insure something in Papua New Guinea is very different to insuring something in Fiji. And I think we would like to see a lot more of this data and performance reporting being shared with insurers so that they can get a better understanding, because I sincerely believe that we're paying too high a premium due to just not sufficient data being available for risk assessment. And I think a report like what Joe and his team have done is a good start towards that. Duties and taxes, most countries have taken on the role and have effectively gone out and said that they want to achieve higher levels of renewable penetration. Unfortunately, for some of the countries, a lot of the targets are not flowing through to creating an enabling environment. There's some countries that still charge duties and high taxes on equipment, which really is not recognizing the fact that as they roll out more renewable energy, their requirements for importing diesel are going to be less over time. So I think there's a little bit of work that needs to be done to encourage governments to ensure that they take into account the fact that rolling out renewable energy, will have an impact on balance of payments at a later date. But one of the things that I really would like to focus on is just the regulatory costs that we've seen. I think Joe's done a good job of capturing capital costs, but across the region as a whole, we are, as a developer, are seeing increasing regulatory costs due to lack of transparency or consistency across the region. We find it incredibly difficult to get what I would call a straight answer from the different regulators across the different regions as to what is allowable and what is not allowable. As an example, we had one project where the actual regulatory cost or compliance cost was greater than $1 per watt. Now, normally, if you're starting in a new region or a new country, you could amortize that over, multiple projects that you will do. But what we've seen is that, you do one project under certain rules, and then by the time you do the second, the rules are changing, and there's not one consistent rule applied. So I guess my question to Joe is, I don't know how much work you've done on the regulatory side, but what work can be done to encourage more transparency and stable rules of engagement to enable scaling of renewable energy projects in the region at a faster rate?
That's a very good question, Paul. So for the cost breakdown analysis, I only managed to obtain 20 project costs, and for 4 of them, it was only partial breakdown of costs. So in fact, I only had 16 data points where I could see the cost breakdowns. And there were, bundling of cost items, like sometimes transport and insurance was just one line item, and sometimes they were separated as 2 separate things. So I didn't include many of the component costs in my summary slide, just because I didn't have enough data points to make a sort of a valid observation, I think. And yeah, the regulatory risk one isn't a line item in any of the tenders that I looked at, but yeah, obviously grid connection can be a very expensive and long process. And yeah, when I'm talking to Pacific Utilities, I'm always encouraging them to put all their guidelines and policies and procedures and metering requirements online so people can know what they're getting into. But often a lot of information isn't published and is difficult to obtain. So I don't know what the answer is. Anthony, do you have anything to add?
No, nothing to add at this stage, Joe.
Okay. Thanks, Paul.
All right, thanks. I think I can hand over to Anthony.
Sure. Thanks, Paul and Joe, for that feedback. So just change slides now, and we'll be over to you, Anthony.
Fantastic. Thanks, Matt. Thanks, Joe, for that good presentation, and thanks a lot for the preparation of that report. I think it's a very useful document for a range of stakeholders in the Pacific. So what I'll do now is just spend 5 minutes talking a little bit about the trends that we see happening in the Pacific in terms of the price movement on renewable energy, and also what we think can be done in that space to help lower the costs. Just briefly, for those who don't know, the Asian Development Bank is a multilateral development bank, along with the World Bank. We're the two MDBs that operate in the Pacific. We focus on both public and private infrastructure financing, as well as technical assistance. And we have about 14 Pacific developing member countries in the Pacific. Just recently actually became 15 when UA have come on as our latest member. In terms of, I mean, a big picture item here, I think, is that we are seeing a massive investment upsurge in renewable energy in the Pacific. For example, our portfolio, 8 years ago, we had one renewable energy project, and today we have a portfolio of 22 projects in 12 countries, and these are projects which are actually under implementation, worth around $450 million US. And in our pipeline for the next 2 years alone, we have 15 projects in 12 countries, worth more than $900 million. So the countries, our member countries, are telling us this is the area that they would like to allocate the scarce concessional lending and grants that they get from ADB. And I understand the situation is the same in the World Bank. And that sort of investment makes us the largest investor in the Pacific energy space at the moment. At the moment, we're seeing that most of the investment in renewable energy is through the utilities, but we are seeing rapid growth in the private sector. So the IPP market is really starting to pick up in several countries in the Pacific. What can be done, and what are the trends we're seeing? So around the contracting, I think Paul mentioned it. In the past, there's been a lack of local experience. I think that's led directly to some high costs. We're seeing now a lot of local contractors getting experience. We're seeing some local Pacific-based EPC contractors who have a much better understanding of the risks of doing work in the Pacific and are able to access some low-cost people in the Pacific. But we are seeing in most countries now local contractors which are now able to team up with international contractors. So hopefully in the future we'll see both locally based EPC contracts from the Pacific, but also a local industry that international companies can team up with to put together teams for these projects, and we'll see a lot more competition in this space. In terms of equipment, I think one is, as Joe mentioned, it's very difficult to get data in this space, but one thing that is clear is the cost of the PV panel now is come down to a point where the main cost is around the EPC costs. So the reduction we're going to see in the overall cost of delivery of PV kilowatt hours from the panel is relatively minor. We are anticipating, I think, as everyone's looking at the battery cost reduction that we should see in the next few years. It's very difficult to get cost estimates of how quickly that will come down in the Pacific. And there also may be some cost reductions around the inverters and the balance of system. On the PV panel, though, the exciting area, I think, is the improvements in efficiencies. Not so much that will reduce the cost of the panel, but because it will reduce the cost of the EPC contract to install those panels. So if you get a X percentage increase in the efficiency of the panels, you'll be able to reduce the footprint of your plant, and that will bring down your EPC contract. In terms of financing, I think long-term, low-cost financing is very important, particularly long-term financing, because that leads directly to a lower tariff, a lower levelized cost of energy. And there's also a bit of work to be done around reducing the financing risk for investors in this space. So, for example, ADB's just recently released a $100 million guarantee and loan product, which is designed to take away some of the provided guarantee, which will remove some of the payment risk on the power purchase agreements that IPPs have in this space. I mentioned a big area of growth in the future is the private sector coming in as IPPs. That's still a relatively young market, and Paul's had more experience than most in this space. We haven't to date seen any secondary IPP market coming in, and the plants that have been built by the private sector tend to be one-off. So we haven't seen emerge any company which has several projects across the Pacific yet, and we haven't seen churn on those projects. So I think the rise of the secondary market in the next year, when there's enough projects in the Pacific to create a secondary market, will really encourage more players into the Pacific, because at the moment there's a lack of exit strategies for companies coming into the Pacific due to the lack of that secondary market. We are hoping that some of the boom that's going on in Australia may flow onto the Pacific. Most companies that have come to the Australian market are very busy at the moment and haven't had much bandwidth to look into the Pacific. But as the boom tapers off in the Pacific, we're hoping some of those companies will be able to look to the Pacific for future projects. I think Paul mentioned the importance of established policies and regulations. And I think that's one area that the development banks and the other bilateral partners through PRIF can help in the Pacific through the establishment and making sure that it's very clear. So when you get private sector investment coming into the Pacific, they know exactly what they're in for and they know what the boundaries are. In some cases, that's adding significantly to risk premiums at the moment. And I think there's other ways that you can de-risk projects in the Pacific to reduce the cost. I think for the private sector, you need to get the land sorted out, you need to get the integration sorted out, and you need to have capacity on the government side for strong power purchase agreements. There have been examples where poor power purchase agreements have led to the financiers for the IPPs being reluctant to enter that deal. So I think having a good, strong counterpart to deal with and a good, strong power purchase agreements is vital for the maturity of the market. And lastly, I guess on the IPP space is just the importance of competitive market bidding. In some other markets, unsolicited bids are possible and often a good option. But for the Pacific, we think strongly that a competitive market bidding process is the best way to secure the lowest cost for these investments. So lastly, just around the operation and maintenance, I think that is something that we'll see evolving in the future. At the moment, you have some cases where the private sector will invest in for example, a solar power plant, and because they don't have resources on the ground, they'll back contract to the power utility to maintain the system. But as we get more and more systems in place, I think you'll have consolidation, and I think you'll have rise of companies which will be able to reduce the operation and maintenance costs across their portfolio of projects in the Pacific. And you may even see, as we're seeing in other markets, the rise of external O&M contractors coming into this space. So I'll leave it there. That was just some ideas about how some of the trends that ADB sees in this space, and also how some of the options to bring down the prices. I guess one thing I'd like to float to Joe as a question is to, I think his report showed that we're seeing a similar price reduction in the Caribbean around renewable energy, particularly around solar, but they seem to have managed to bring the price down to 10 cents to 15 cents, whereas we're still up around higher than that, up to double that in the Pacific. They should have, I think Joe's clearly shown the difficulties in collecting data, but I'm interested in why we're not seeing similar prices that the Caribbean gets, given that the Caribbean should have similar constraints that we see in the Pacific. So thank you, and back over to you, Joe.
Yeah, so I'm not an expert on the Caribbean, but I would possibly hypothesize that it's not as remote as the Pacific, in that the US is quite, what's the word, the travel distances to the US aren't as far as they are in the Pacific, so your transport costs are going to be much less. And then the loads are much larger in the Caribbean as well. So the projects are at the 5 megawatts and above scale. So they've got that economies of scale benefit by doing those larger projects. And what's the word? The economies of the Caribbean nations, because of the tourism industry that they have, they're probably got more local capacity to help with the construction of the projects, would be my theory. Do you want to add anything, Paul?
No, Joe, I think you're right in terms of, from an economies of scale perspective, they definitely have larger projects, and that we see that whenever we do projects that are on the larger end of scale, that your cost per watt drops. And definitely from a transportation point of view, they are an advantage. I mean, there's some countries where we literally have to book a container in, and it will take about a month just to get a container on to be loaded on from China to a certain country, whereas they will probably have a lot more volume of freight between them and the US. So and that helps a lot.
Yeah, and they probably have more frequent shipping schedules as well. So yeah.
Great. So I might just take over the reins there. So thank you, Anthony, and thank each of the panelists for these outstanding questions and comments. Just a general reminder, as we shift towards the Q&A session, there's still opportunities to ask as many questions as you like, and we'll continue this going until we have no longer any questions to answer. So we already have some great questions from the audience coming in. So we'll use this remaining time to answer those questions. So I'll read them out so you guys can all have an opportunity to respond to them. The first question, has there been any focus on gender effects or free, prior and informed consent as part of these projects? Local consultations and so on may also have costs. Can these be measured? I guess the question the externalized costs that may not be necessarily included in the technical breakdown. Maybe Joe, you might be able to answer this, start with this question, and maybe Anthony and Paul take the reins after that.
Yeah, so in Annex A, you'll see that many projects, the announced funding is quite large for the scale of the project, and that's because the project will often include capacity building and training, and you can even see O&M included. So yeah, so those activities do occur and they do take time and money, but the tender documents that I managed to obtain to do the commercial and confidence cost breakdowns was the EPC tender documents, so that's why it focuses on those technical costs. But yeah, there are definitely many costs in getting from concept to project that are required in community consultation, and what's the word? The employment effects for the local people and the gender issues are taken into account in the project development life cycle.
Great, thanks, Joe. Any comments from Paul and Anthony on that one?
Yeah, I can add a little bit. Sorry, you go, Anthony.
Oh, thanks, Paul. So from ADB's perspective, gender plays an important role in the when we assess the project and when we complete the feasibility studies and when we build the gender components into the project. So, for example, you have gender awareness training within the power utility. You have target percentages of gender of female staff on the contractor side. But I guess the biggest benefit is really when you're increasing access to power. So, for example, we have some projects in Papua New Guinea at the moment where you have the opportunity to pre-identify single female headed households and prioritise connection to them, and then ways to train families on how to use the power. Firstly for safety wise, but then also for income generating activities, and that has a disproportional benefit to the to the females of the household, because they tend to be at home and they tend to have the opportunity to value add using that electricity. The actual impact on the cost of the project, from our perspective, I don't see it being major. A lot of that support comes in for our projects on a grant basis. So that's sort of an add-on to the project cost, and I don't think that tends to be an externality that flows through to the cost of power from these systems. It tends to be an add-on. From an economic perspective, I think it has a very strong benefit to the project. From a financial perspective, it doesn't have such an impact, but on an economic benefit perspective, it has a strong impact. Thanks.
If I just add to that, I mean, what we're seeing is that we're seeing a lot more emphasis on community engagement, and as we operate in multiple countries, we are, off the bat trying to make sure that we localize as much of the labor as possible to ensure that we build capacity and capability across both genders. At this stage, we haven't had a specific like a gender target to reach or to hit, but we are definitely seeing a lot more community engagement and requirement for us to build the connection with the community, who will ultimately look after the assets that we put in place and will benefit from them.
Great. Thanks, Paul, for that, and thanks, guys, for that response. The next question, do or should battery costs take into account inherent civil and transportation costs to give a better reflection of total cost of lead acid options versus lithium-ion options? Perhaps Paul, Joe, you might like to respond to this.
Yeah, so the cost template, I've basically itemized the costs as much as possible, but still making the template as user-friendly and easy to use, so it doesn't take forever to fill in. So in the storage area, I've tried to capture just the component costs of the battery, and then there's a separate line item for transport in the other costs. And yeah, you're right that lead acid batteries are a lot heavier and bulky than the lithium-ion batteries, so there will be additional transport costs. But the way I've set up the template, the transport cost is just a separate item, so you just have to, factor that in when you're looking at any comparisons. But yeah, that's a good question.
Any comments? Yeah, thank you. Any comments from Paul or Anthony on that, or should we continue to the next question?
I don't have anything to add. I think Joe's captured that quite well.
Sure.
No, nothing from
so the next. Great, thank you. So the next question is quite ADB specific, so over to you, Anthony. Does ADB provide financing for pilot projects for market penetration? If not in ADB's scope, who can then provide these small funds or kick-off projects?
Yeah, thanks. It's a very good question. I guess we tend to work closely with the power utilities in the Pacific. They tend to have a fairly good idea of the priority technology that they'd like to work with. In some cases, if they don't have a planning document, we help them finance preparation of a planning document so that they know that they're investing in the least cost and the most appropriate technology for that country. In terms of pilot projects, we sometimes advise, and the utility sometimes request, that we do a small project first to make sure that it is suitable for the country, and then that is then upscaled at a later stage. If you're talking about pilot technologies, to upscale pilot technologies in order to bring the cost down, It's not something we tend to finance in the Pacific. We tend to like the technology coming in the Pacific to be robust with strong supply chains. However, in some cases, on exceptional basis, that occurs when it makes sense for the country and the country requests it. Other financiers for pilot projects, and I'm assuming here we're talking about new technologies. Some of the UN agencies provide those pilot financing, but apart from that, nothing comes to mind about financing of those pilot projects. Thanks.
Sure. I'll just continue on to the next question because we're getting quite a lot of questions coming through, which is fantastic. So the next question, what other renewable energy technologies do you guys think can be utilised in the Pacific apart from solar PV and wind? I think this question particularly responds to perhaps maybe bioenergy, but also other technologies involved in the Pacific. We'll start maybe with Joe on this one, with your extensive experience in the Pacific region.
Yeah, so my only comment to that question is, yes, bioenergy does have a lot of potential in some parts of the Pacific. It can have high operation and maintenance requirements, which affects the costs, so that can be a challenge. But there's even opportunities in the waste to energy sector potentially, but that's also a very costly technology from what I've seen with Australian deployments. There's also the issue of feedstocks for your bioenergy and waste to energy plants. As soon as you introduce a bioenergy plant, the cost of feedstock tends to go up. And transporting bioenergy is also expensive, so you can't transport at large distances. Wave power offers great potential, but unfortunately it's still way too expensive. And my understanding is the wave resource tends to correlate with the wind resource, and the Pacific isn't blessed with a huge wind resource or a huge wave resource, is my understanding. So yeah, I think if we were to expand the scope of work for this sort of analysis, considering including bioenergy would be worthwhile.
Great. Any comments on that, Paul or Anthony?
I think Joe's captured that, that very well. There is room for other technologies, but they have to make commercial sense for them to be viable. So, and as Anthony pointed out earlier on, for the Pacific, I think the preference is to make sure that whatever technologies we take must have a proven supply chain to ensure that, they can be supported going forward.
Yeah, Paul, just to add to that, I think specifically talking about bioenergy, waste to energy has some potential in the Pacific where you've got a secure supply stream, mainly because some of the atoll countries have such a secondary issue of how to just dispose of the waste. So if it can help them both with their energy generation plus some of their other issues in terms of waste disposal, it has a win-win. In terms of future, I think wave would be great because if it could be, if you could have small generating units sitting off the coast of some of these some of these islands that have small towns with limited road access, you could provide localized energy sources. But again, as Paul said, it's just, and Joe mentioned, it's just a bit too expensive at the moment.
Sure. Thank you, guys. We'll move on quickly to the next question then. On the topic of recycling costs for batteries, how do you think these should be handled in the number of solar projects increase and the batteries eventually need to be replaced? Any comments on that? Perhaps Anthony, you might be able to start this one.
Yeah, thanks. So just some general comments, and I think probably over to Paul, who's probably been grappling with these issues on his specific projects. So it's a big consideration, and particularly around the volume of batteries it will be in the next 5 years will be going to the Pacific. The lead acid batteries seem to be less and less of an issue at the moment because most new projects seem to be moving into lithium ion storage. However, getting those back, there's various ways you can do that, having return policies with the suppliers, but in many cases these are being pushed back to be sorted out at a later stage. So that's something that we're very conscious of, that we need to be thinking about that and putting that into the long-term contracts up front. I think the key to this, though, will be to be establishing a viable recycling business in the Pacific that will actually go out and source these and be able to make a profit out of these, out of the batteries across a huge area in the Pacific. And I guess that's one thing we're looking to tie into our future bidding documents. Paul, would you have any comments on that?
I mean, I agree with your comments there, Anthony. What we are starting to kind of like starting to think about is adding these into the contracts for return. But you're right, everyone pushes back, and the long-term solution is recycling either in the Pacific or in Australia and New Zealand, because this problem is going to be a region-wide problem, and it needs a regional approach to it. At a country level, I just don't think there is sufficient volumes in each of the countries to operate a recycling business, but across a region, including Australia and New Zealand, as the technologies is being utilized at a similar pace, the scale that you would get when you combine the region as a whole will make recycling, centralized recycling a go.
Great. So thank you both for that comment. This next question comes to. Oh, sorry, Joe, continue.
Quickly add that PRIF is actually doing some work in this area, and they've published an overview. The Pacific Region Solid Waste Management and Recycling Report is publicly available, and further work is definitely going on in this area because it is a growing issue.
Great, thanks, Joe. And the next question is directly targeted at you as well. You mentioned there was scope to encourage PV rooftop installations. In addition to publishing tariffs, what other strategies could be used to support deployment?
So in Australia, the deployment was accelerated with a financial rebate from the government, which is no longer available. I don't know whether that would work in the Pacific, but having a feed-in tariff that's fair may be sufficient, but there's still many barriers for the deployment of rooftop PV where people don't understand the technology. But one thing I would encourage Pacific governments to consider is ensuring that their buildings have got rooftop PV systems, and schools are another great location usually for PV. And the metering and the connection requirements for connecting need to be clear and easily available. But yeah, that's all from me on that one.
Sure. Any comments on that, Paul?
I think Joe's captured that quite well. It's having a very public or well-known and understood feed-in tariff is one way, but I do, from having worked in the region, I'm aware that this is not always. There needs to be some work done at the utility side to show what the impact will be by accelerating uptake, and to make sure that what is perceived to be a revenue reduction for the utility is offset by a much broader goal around improving the balance of payments. And in some cases, we've been able to show that increasing renewable energy actually improves the economics for the utilities, but that needs to be done at a much broader level. Great,
thanks, Paul. We'll just move on to the next question because we've still got plenty of questions coming in. I'm worried about time. So the next question Is there any plans by any Pacific Island country or regionally to include emission costs in the overall energy costs? So this is particularly targeted at diesel generation, but perhaps there might be some other technologies being used in the Pacific. Maybe Anthony, I don't know if you're aware of anything like this in your space.
Yeah, thanks, Matt. To my knowledge, none of the Pacific countries are looking at any sort of tariff adjustment to or economic disincentive for emission reductions around the tariff. They're all highly aware of their emission targets. They all have very strong renewable energy targets, and I think they're working, rather than looking for market incentives to decarbonise their energy sector, I think they're just working directly very hard with the energy departments and the power utilities to decarbonise their diesel fleet. Every country in the Pacific has strong renewable energy targets, and all the power utilities have plans, some more advanced than others, in terms of bringing in renewable energy. And apart from the financial benefits, one of the strong drivers is to reduce the country's emissions.
Sure, thank you. Any other comments from either Joe or Paul on that, or should we keep going to the next question?
Nothing from my end.
Just a quick comment. Some Australian companies will do a sensitivity analysis to carbon pricing when making investment decisions. So they're not actually factoring it into core business, and they're not paying a carbon price, but they are doing a sensitivity analysis to help them make decisions. And that could be a way of introducing this to the Pacific.
Great, thanks. So the next question's asking about the operations and maintenance of plants post-delivery. Have there been any measurable studies on actual sustainability effectiveness with a time span about 3 to 5 years after delivery on the Pacific projects? Anthony, is there anything written into grants or tenders to include this, or is this what is your experience in this space?
Yeah, so no, it's a really good question. The majority of the investments have gone in the last 3 to 5 years in our portfolio, but we do have ongoing dialogue with the government, so that if we do finance the next round, we monitor the performance of previous investments, and that informs our design for the next investment. So it is monitored when there's an ongoing portfolio of projects being delivered in that country. I think it is, and when we close down a project as well, when we finish the financing analysis, we step back and look at the initial results from those projects, and then to gauge whether the economic benefits and the financial benefits are anticipated to be realised. But that's relatively soon after the project has been installed. So there is, I think, some work that could be done around checking the performance of particularly solar grids, particularly solar installations in the Pacific, as opposed to what the predictions were in the feasibility study level. I guess that might be something Paul would have a feel for, given that he's got several installations across the Pacific which have been operating for several years, so he may have a feel for how they've performed against their initial projections.
Thanks, Anthony. I mean, we've been operating plants for the last 7 years, and we do measure this on effectively on a monthly basis, and we do a look back based on what we expected because of the financing structures that we have in place. On the whole, I would say we probably about, if you asked me this question, 3 years ago, I'd have said it was kind of like a shot in the dark. Now because we've been operating for a long time in the Pacific, we do measure this, and the quality of the data that we're seeing or using for modeling for future projects comes off from more live projects rather than theoretical data, which is where we started. So I would say we were probably about 80% of plan. We're probably closer to 95% of plan, because we've been operating in the region for a while now, and we're able to refer back to our normal, not just the theoretical design specification, but the performance that we see in each of the regions. So we do measure it, and it's part of our financing covenants to make sure that we are, operating at about 90% of plan.
Thanks, Paul. So next question. So the study is focused on large-scale renewable projects. Is there scope to look at costs on outer islands specifically? Does this information exist? But also, adding to that question, there are a few questions on small, like mini hydro and small solar and storage systems in general. Is there any scope to measure the costs and maybe what are the of those projects, as well as the regulatory barriers? Maybe Joe, you might be able to start on this one.
Yeah, so the smaller the project, the less information that tends to be publicly available for it. So yes, theoretically, you could analyze the costs of smaller systems. But yeah, my expectation would be finding enough data to do it would be the challenge. And then, there's individual projects versus programs where 50 to 100 systems are rolled out, which gives you a very different cost structure. And then my other comment is the smaller the load, the more economic the solar and battery options become, because the diesels don't like those small loads and their efficiencies drop when they're lightly loaded. So yeah, there is definitely opportunities for solar home systems, and in the outer islands where diesel prices are highest, solar is a good option.
Maybe I can just add something.
Sure,
Yeah.
Go ahead.
I think from PRIF's perspective, speaking as one of the members of PRIF, when this report was originally put up, the concept is to have it as a rolling report. So hopefully within a 1 or 2 year space, there'll be enough projects, and then we can track to come back and redo the report, and then there'll be of course, depending on pending available resources, but that will give you then a trend line of costs in the Pacific, and it will also give you, if you can collect more data, you can then start looking at the smaller outer island cost points. So, for example, in the Solomon Islands at the moment, the utility there is leading a rollout of both conversion of the existing provincial grids with some support from ADB, and also a series of new small 100 kilowatt size range hybrid systems, solar diesel systems in a range of new sites. So there, in 1 or 2 years' time, if the report is redone, I think we'll have a lot of good data, not only on the main larger installations, but also on the smaller installations. I think the key here is to extract that data from the utilities and make sure they're happy to share that data. But I think that is an area where this report could present that data into the future.
Great, thank you. Thank you both. This next question regarding the clean development mechanism. What's its importance and relevance for projects in the Pacific? Anthony might be able to continue on this point.
Yeah, thanks. So the CDM is not featuring at the moment. In the past, we were involved in some work on a couple of transactions up in Papua New Guinea for some hydropower plants, and ADB had a fund which forward purchased credits, so that money has flowed. and there was, from memory, this is a few years back, some projects in Fiji that were also assessing that. But at the moment, the CDM as a mechanism of leveraging climate financing is no longer supporting any projects in the Pacific, to my knowledge. That said, there's a range of climate financing entering the Pacific. You have the Green Climate Fund, which ADB and the World Bank are both implementing agencies for, accredited entities, and also there's a range of other entities in the Pacific which are currently accessing the Green Climate Fund, and then there's a range of other climate funds which are coming in to support projects directly. Thanks.
Cool. Okay, thank you. This last question, perhaps, so it's going back to our point about biogas and bioenergy. If you take what's its feasibility if you took a circular economy approach, maybe a more regional approach, and try to capture addressing water, food security, energy at the same time? Could more projects come out of that viability? Paul, I think you had a few comments on this, and maybe you'd like to continue on that point.
Sorry, could you repeat the last part of the question? I just want to make sure I'm answered correctly.
Sure. I think the last point was like if you took a more water, energy, food nexus approach, if you address water, food security, and energy at the same time, could biogas become more feasible?
Yeah. I guess the answer to that is probably yes, but it would have to, from a developer's point of view, we're then effectively then solving a broader range of a broader range than what we normally would do as an energy developer, and that would have to come through, from a program that the government sees us as being part of a solution, that it's all done at the same time. From a energy development point of view, while we can see the benefits, we don't have the experience with our organization to be able to cover the whole gamut, but it would have to be a much broader solution or request from a government that brings together players across both sides of the spectrum.
Sure, great. So I might just start to wrap up what was a great Q&A session, but we're in time, so we might just wrap up now. So I'd like to thank you panelists for that informative session. For any questions that we didn't get time to, we'll connect with those attendees offline after the webinar. I'd like to provide the panelists with an opportunity to provide any additional closing remarks you'd like to make before we close this webinar. Joe, do you want to make any comments about the report more broadly that you didn't get a chance to comment on?
Oh, no, just to thank again PRIF and ADB and Clean Energy Solutions Centre for organising this webinar, and also the report. And thank you to the participants for their time.
Great, thanks, Joe. We'll just change slides. So on behalf of the Clean Energy Solutions Centre, I'd like to extend a thank you for all of our expert panellists and to our attendees for participating in today's webinar. We very much appreciate your time and hope in return that there were some valuable insights that you can take back to your ministries, departments, or organisations. We also invite you to inform your colleagues and those in your networks about the Solutions Centre's resources and services, including our no-cost policy support through our Ask an Expert service. I invite you to check the Solutions Centre website if you'd like to view the slides and listen to a recording of today's presentations, as well as previously held webinars. Additionally, you will find information on upcoming webinars and other training events. We are also now posting webinar recordings to the Solutions Centre's YouTube channel. Please allow about 1 week for the audio recording to be posted. Finally, I would like to kindly ask you to take a moment to complete the short survey that will appear when we conclude the webinar. Please enjoy the rest of your day, and we hope to see you again at the future Clean Energy Solutions Centre events This concludes our webinar for today.
Thanks, Matt.